Okay, hello everyone. Today we are talking about chapter 9.2. Chapter 9.2, that is the condition for congruent triangles. In last session, that is the chapter 9.1, we talk about what is the meaning of congruence. What is the meaning of congruence? That is, the figures are totally the same. However, the length or the angles are all the same. Okay. So, we know that, for example, in these two triangles, if we know that these two triangles are congruent, the symbol is this one, triangle ABC is congruent to triangle PQR. We know that the corresponding length or corresponding angles will be equal. For example, AB will equal to PQ, the angle BCA will equal to angle QRP. You can see that I use different color to show that the point to point is very important. That is, the order is very important. For example, we can say A boy is equal to PQ because A is corresponding to P. Boy is corresponding to Q, right? So do not say that BA is equal to PQ because the lengths are not in order, right? The lengths are not in order. So remember, the order is very important in this chapter. So what's in this chapter 9.2, what should we learn? That is, we learn it in the other way. That means last time we have these congruent triangles, then we can have this condition, right? That is, this one is the properties, or I may say the properties of congruent triangles. So in this chapter 9.2, we are going to learn it in another way. That is, from this one to this one. That is, we want to have this condition to prove the triangles are congruent. We want to prove whether the two triangles are congruent or not. So if you have read the books in page 29, you can see there are totally 5 conditions to prove the congruent triangles. This is called the SSS, SAS, ASA, AAS, RHS. And some of you maybe have already heard about a famous song that's about the sine, angle, sine, right? I'm going to show you part of it. If you are interested, you may search in the Google.
I think I can remember those conditions now.
Oh, I can make it even better. We can dance. Yeah. Let me show you.
Sine, angle, sine, 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 angle, triangle, angle, angle, sine.
Okay, if you are interested, you may search it by yourself. I'm not going to show you all the video. Okay, so you can see there are totally, we have 5 conditions, right? Sine, angle, sine, 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 angle, sine, angle, 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 sine, and the last one. And in fact, the books has already told you RHS, right? In fact, the YouTube, the team of those students is called RHS. So totally, they've already talked about the 5 conditions to show congruent triangles. So today we are going to analyze these 5 conditions. First of all, we can see that all of them are consist of 3 alphabets, right? 1, 2, and 3, right? All of them are 3. And also in the first 4 conditions, all of them are consist of S or A only, right? Just in different orders, or the number of S is different, right? For the S, it means the sine. That means there are 2 corresponding sides are equal. For A, it means the angle. Okay. Then, how about the last one? That is the RHS. This one is special. For R is right angle. That means if there is a right angle triangle, this one is the right angle. So in fact, it's also talk about an angle, right? Just talking about an angle. But this is a special one only. For the H, it means hypotenuse. In fact, it is also in the right triangle. This line this one we'll call it hypotenuse. In Chinese, it's called 斜边. Hypotenuse is the opposite side of the right angle. Also, it is the longest length in the right angle triangle, right? It's the longest length. So, these 5 conditions can prove the congruent triangles. For example, if this 9 and SSS, if these 3 9s, this one is equal to this one is equal to this one, and the last side are also equal, we can see that the triangle will be congruent, is totally the same, right? So we can prove it like that. You may ask, why these 3 conditions can make sure the 2 triangles are the same, right? And I'm going to show you some of the conditions. For example, for the first one, SAS. For example, if I have two triangles, first of all, I give you one point. There's A and a P. SAS, that means we have 2 sides equal, and the angles in between the 2 sides. This one we call it included angle. So we cannot write down in this one SSA or ASS. No, because the order is very important. This one is the middle in between the 2 sides. What does it mean? For example, if these 2 triangles are the same, this 9 equal to this one, this 9 is equal to this one, then the included angle must be in between these 2 sides. That is this one, right? This angle is in between the 2 sides here, right? So this one is the included angle. That is the SAS. So I'm going to show you why SAS must have the congruent triangle. For example, the point A, point B, we match it first, and then we have 2 lengths are the same. For example, this one and this one, I call it B, I call it Q. And then for the another side, that is, for example, this one, it's the same, are the same. I call it R, I call it C. Also, the included angle, that is this one, included angle, are also the same. Then we can form these 2 figures, right? But we know that for a triangle, we should have 3 sides. So we can simply join these 2 lines. Draw these 2 lines. Then we have 2 triangles. And because these 3 points are already fixed, right? These 3 points are already fixed. So these 2 lines must be the same, right? Must be the same. And also the angle will also be the same, right? This one will equal to this one. And then this one will also be equal to this one, right? So we can see why SAS will be a condition to prove the triangles are congruent, because the points, we go back, because the 3 points in fact are already fixed, right? That's all. Why SAS is one of the reasons to prove congruent triangles. And I'm not going to show off these 5 conditions. If you are interested, you may search it in Google or in YouTube. And I want to talk about one more thing. That is, some of you may find that these five conditions do not have AAA, right? Do not have AAA, right? We have SSS, but we do not have AAA. So I'm going to tell you why AAA cannot be a congruent triangles. So for example, I draw a triangle. Okay. For example, ABC. These 3 angles, I mark it in different colors. B is use red colors. For the C, we use green colors. Okay. So for the length of AB, I'll mark the length here. AB, the length is about here, right? AB, I mark the length here. Okay. So now I'm going to show you why AAA is not a condition of congruent triangle. For example, I hold the all triangle ABC, and then I enlarge the triangle. That is, enlarge, making bigger. You can see the angle ABC, the blue, the red, the green angle are still the same, right? But you can see AB here is longer, right? This side is not the same as this side, right? So we can see the two triangles are not the same because the length are already different, right? So that's why AAA is not a congruent triangles condition. Okay, so for how to do the exercise, or how can we write down the step to prove the congruent triangles, I'm going to show you in the next video. Okay, that's all.